Good morning again, everyone. Thank you so much for joining us today. My name is Stacy Dees, and I'm the program manager for the NASA RASCAL Challenge. And we're really excited to have all of your participation this year. This year marks the 20th anniversary of the RASCAL program at NASA, so it's kind of an important year, and we have some really exciting themes this year to commemorate that. Before we continue, I would like to just one more time ask everybody if they could mute your phone and your computer mics, just to make sure that we can hear everybody, that we can hear all of the questions and answers. The session is being recorded, and we will actually post a link to the recording. So if you'd like to go back and listen to anything you might have missed, that will be available to you on the RASCAL FAQs page a couple days after we finish up with this Q&A session. We do have almost 200 questions that you all submitted to us. So we have a lot of questions to get through in the next 90 minutes. So I'm not going to belabor this any longer. Let's just go ahead and, Jen, would you please go ahead and go to the next slide? So this is just a quick agenda, a look ahead as to how this Q&A session is going to be handled. I'm going to do some introductions for you really quickly. You'll get to hear a little bit about the background behind the 2021 RASCAL Challenge. And then we'll just start going through those questions that you all have submitted to us in advance. We have some generic technical questions and some programmatic questions that we'll address first off, and then we'll go through theme by theme. And so that way, if you've already heard from your theme and you need to drop off, you can feel free to do that. Like I said, the full audio of this will be posted, as well as a written transcript with a written response to all of the questions that you guys submitted to us in advance. And if there's time at the end, we will get to any additional questions that you may have. But time will probably likely be tight right now. And so what we're going to do is, if you have questions as you're going through, go ahead and just drop those into the chat, and we will answer those as we can on a first come, first serve basis. If we don't get to them by the end of our session today, we will address them in writing on the FAQ. So we want to make sure that we get all of your questions answered so you guys can have amazing concepts to submit to the challenge this year. And we'll wrap up and get you out of here by 12:30 Eastern time. So let's go ahead into the introductions. Our RASCAL team is managed by a program staff that it consists of Shelly Spears, our program director, myself, Stacy Dees, the program manager, and Jen Eberly and Tori O'Leary, who both support the program. And you'll most likely be hearing from myself, Jen, and Tori as we move through the year with the RASCAL program. Next slide, please. And then the bread and butter of our RASCAL of the RASCAL program is our steering committee. I'm not going to go through everybody right now just for the sake of time, but know that they are all listed on the judges page, the steering committee page for the RASCAL on the RASCAL website, and you can look at their full bios and learn a little bit about their backgrounds. But we have a stellar, top-notch, talented, intelligent steering committee that helps develop the themes and judges all of the deliverables that you have for the challenge. The two gentlemen that you see there that have a red box surrounding them are Dr. Christopher Jones and Pat Troutman, who are both NASA Langley Research Center based and are the ones who are responsible largely for making sure that RASCAL is funded every year and come up with all of the great themes that are very relevant to the work that they're doing. And those are the two gentlemen who are on the call with us today. Go ahead to the next slide, please. All right, so before I turn the mic over to Pat Troutman to talk a little bit about the context behind the challenge and what NASA is hoping to get out of it this year, I just one more time would like to ask everybody if they could mute their mics. We are hearing just a little bit of feedback. Thank you for that, and Pat, the floor is yours. And Pat, if you're talking, we can't hear you.
Because you have to double unmute your mic in WebEx, so sorry about that. All right, so a little context for RASCALs. RASCAL's been around for a decade or so, and it's always been used as a bellwether of maybe where we could go. So we try to cover topics that reflect where NASA is going, And we also have themes and topics that could explore where we might go. So folks who have participated in RASCAL usually get a sneak peek of somewhere our strategic thinking is going because we ask for folks to look at concepts along those lines. And those concepts, believe it or not, shape how we think about pursuing things. If there's a lot of interest in a certain concept or a mission, that says something about for how the general public and the technical community feels about that, influences our thinking. The innovation and ideas coming up in those architectures and concepts, we do glean from those and factor them in whenever we can, where it makes sense. We get more productivity and more efficiency and greater mission return from them. And then the third really reason we do this is there's not a lot of capability out there in the university community that thinks about grand strategic visions and mission planning from all perspectives at a very high level. There's fantastic schools out there that talk about how to design a certain thing or very deep into technology. But when we're talking about the strategic mission planning, this is our chance to plant the seeds of thinking that type of mission context within the university community, within the students. And then it becomes almost a job fair for NASA, because we've hired a lot of folks from RASCAL who've demonstrated incredible systems thinking and at the mission level, who have the gusto and the enthusiasm for doing these type of missions. So it helps us with ideas, it helps us understand what people think, and it gives us a good workforce base. So the challenges you see this year reflect some things NASA are working on, which are the Moon and Mars, and reflect some other things that we're scratching our heads on, and you'll see Venus and Ceres in there. I'll just put Ceres is in there because Mars is so hard not to get to the planet itself, but to get down to the surface. Ceres is a little harder to get to, but it's very easy to land on the surface. So you can think of Ceres as a different set of challenges than the Mars mission, but one that's not any harder or easier, just different in nature. So that's the context for moving forward and sort of why we selected these missions.
All right. So with that, let's jump right into some of the miscellaneous technical questions that came in. Jen, if you could go to that next slide. The first question, what are your expectations for the 2021 NASA RASCAL competition?
Are you fielding these, Stacy?
I'm going to have you answer them, Pat. How about we'll have you answer one set and then we'll have Chris answer the other set. How about that?
How about this? You do the ones that are general about the competition, and Chris is going to do Ceres and Venus, and I'll do the rest.
Sounds like a plan. All right.
All right, you're on the spot.
All right. So then to answer that question, innovative mission designs that meet the requirements that are within a reasonably realistic vision of the future. That's what the expectations are. I'll tell you what, Jen, will you read these questions and I'll answer them?
Sure, Stacy. Question 2, is this a NASA-only mission? Is international cooperation possible?
International cooperation is absolutely allowed, but don't assume that their participation is free. You want to make sure to include their costs if you use international partners.
Question 3, are there any limitations, constraints due to space law that should be considered?
If you identify a conflict, note it, but don't let it constrain you.
Question 4, can people from NASA preview our design before submitting our proposal?
So the answer is yes, with a couple of exceptions. As long as they are not a RASCAL steering committee member or not a member of the sponsoring space mission analysis branch at NASA Langley.
Question 5, can we use already existing technologies such as spacecraft, habitats, and science instruments in our mission?
Absolutely.
Question 6, what inflation rate should we assume for the cost model? Is there a specific time value of money year we should use, i.e. $2020?
$2020 plus 2% inflation is a really good starting point, but we want to allow teams to be able to go beyond that. If you feel you might have a better assumption, as long as you justify it and document it, you don't have to stay within that constraint.
Question 7, what level of depth, how much technical detail is expected for the proposal paper and video?
So we provide a lot of detail on the RASCAL website, the deliverables page, specifically under the proposal section. That includes everything that we're looking for, including the level of detail. But just at a really high level, you must demonstrate an understanding of the realistic trade space for technology, operations, and affordability.
Question 8, what TRL level can we propose?
We want you to demonstrate how the technology is matured to operational status prior to your mission date.
Question 9, how much modeling and simulation is expected for the proposal?
You should really be focused instead on where you need to make design decisions.
Question 10, can you provide specifications and technical data on the ECLSS system on the ISS as a benchmark for our potential systems?
So we actually do have a couple of documents and links that we are going to add to the RASCAL resources page very shortly after this presentation. So take a look under the recommended reading of the RASCAL page within a day or two, and we'll have some new links that will provide information for you to answer that question.
Question 11, what costs are to be included in the project budget? i.e., will it consist strictly of the habitat and required systems for operation and life support, or must it include NASA operations as well, such as costs associated with launch?
You want to include all costs related to technology development, design, production, launch, and mission operations.
Question 12, should we provide consideration regarding crew composition, or should we assume to already have an optimal crew available for such a mission?
We want you to tell us what you think the optimal crew should be and why.
Question 13. Is there a general methodology that we should follow as we make progress in our team's project?
Just follow the rules and guidelines that are outlined for you in all of the deliverables. Okay, and now we're moving on to some of the programmatic questions. And Jen, I'm just going to have you continue to read these, and I'll address these ones as well.
Question 1. Due to COVID-19, is the competition still expected to be in person?
So at this time, yes. But like everyone else in the world, we're going to monitor and watch and make any changes to that decision as we come near to the time when we have a final time to make that decision, probably in the spring. But we're hopeful that we will be able to gather in person, yes.
Question 2. Is there an expected length for the final report?
Okay, so before I answer this, I just want to remind everyone that a lot of the questions that we received are actually already addressed on the website, on the information for each of the deliverables. So definitely go back to the website and check out each deliverable and what all of the requirements are. And we pretty clearly indicate what those are. For this particular question, the length of the final report needs to be between 10 and 15 pages.
Question 3. Should the final proposal follow AIAA format, or is there another standard to follow?
So we don't have any specific standard format other than what is listed on the RASCAL website for the proposal formatting.
Question 4. Are there any additional ways to communicate or ask questions with RASCAL regarding requirements in the future?
Absolutely. If you have any questions that come up after the Q&A session, please email us at the generic RASCAL email address, which is all over the website. It's rascal@nianet.org. And we will provide a written response back to your team, as well as provide that information on the FAQ page so that everybody else has access to the same information. We want everybody to have a fair and even playing field and that you all have access to the same information. So any question that we address, we will post to the FAQs page. So we really encourage you to check back to that FAQs page pretty frequently up until the time that you submit your proposal.
Question 5. Has the requirement that the student team members be full-time students been waived for the 2021 competition?
Yes, we have actually expanded eligibility to allow participation from both part-time and full-time students.
Question 6. Are appendices included in the minimum or maximum page limit of the technical paper?
Again, this info is on the website. We do allow appendices that do not, they're not included in the minimum or maximum page limit, but we do ask that you use those appendices wisely for references only.
Question 7. Are there any page limits or page count guidelines for text versus figures in the technical paper?
No.
Question 8. Are we allowed to take advice from a space company for the project?
Absolutely. We actually encourage you to use any resource available to you that will help support the development of your RASCAL concept. So that could be additional faculty, that could be folks in the aerospace industry, it could be NASA folks with the exceptions that we listed earlier. Use any resource that's available to you.
Question 9. Is there a pathway for live consultations with engineers at RASCAL or an associated facility? And what is the best way to pursue those consultations?
So our staff is not a matchmaking service for those types of consultations. We ask that you make your own connections and utilize resources within your network to do so. And with that, we are getting ready to delve into the Theme 1 questions. So I believe this is one, Pat, that we're going to have you respond to. Is that correct?
That is correct. I'm going to do 1 and 2, and Chris is going to do 3 and 4, and we'll argue over 5, if there is a 5.
Sounds like a plan. Well, then under Theme 1, which is the durable, low-mass, lunar surface habitat, what are the expected deliverables?
All right, so Stacy's pretty much emphasized that plenty. Please go on the website and read all the things we're expecting. We've had teams in the past who simply left out a few key things that would have taken them 15 minutes to do, and it drops them from the competition. So go back to the deliverable page, read it, see what we want you to show us, and repeat that and play it back to us. That's how you're going to get competitive.
And is there a specific software program we should use to model and analyze how our habitat can survive the lunar condition?
Absolutely not.
Should we have a specific launch vehicle in mind? Are launch providers or service providers specified for the project? And if so, what are the limitations of the specified service in terms of mass, volume, cost, etc.?
So in the past, we have specified specific launch vehicles because it was pertinent to the NASA architecture, and we didn't want people straying outside of that. We're fairly open now with that because we have a whole host of great commercial providers coming on. So you pick and justify it.
Perfect. Moving on to the next slide. If launch services are not specified, do we need to concern ourselves with the logistics of transporting the habitat to the lunar surface beyond selecting a launch service provider?
Yeah, you get to describe how it gets there, and that includes launch, phasing and landing. The landing parts could be tricky because NASA hasn't defined a lander yet, and we're competing against, we got 3 people out there with lander concepts. So you're going to see later on someone ask about the landers. And what I want you guys to do is I want you guys to take what's available publicly with respect to how things are landed on the lunar surface, how the 3 contractors, we have Dynetics, we have SpaceX, and we have the Blue Federation. There's very high-level information out there in public. You're free to contact them directly and say, hey, if you were to convert your human lander into a cargo lander, how much could it get down and how big would the payload be? Or you can extrapolate from the data that's publicly available. But yes, it can't just magically appear on the surface. You have to tell us how it gets there and what your assumptions are. And as long as your assumptions are sound and based on things that are in the pipeline or people are looking at, not transporters and stuff like that, we'll give you credit for it. But you have to document your rationale and your assumptions.
Thank you for that. Next question. Are there any constraints that are not listed?
We have no secret constraints. If they're not there, then you're free to play with it at spring.
Wonderful. And are you biased towards any subsystems that we could use in our HAB?
Well, certainly I am, but I'll never tell.
Fair answer. Moving on. Besides the basic functions needed for supporting human life, are there any special functions you want the HAB to be able to perform?
So think of supporting the crew for the specified duration as a minimal floor. They need something to do there. They want to be productive. We're sending people to the moon to explore and do science and discover. There's also the fact that people at the moon is very interesting. So of course we want to see what they're doing. So it's up to you but some functions can be added for a very small mass penalty and have a great impact on mission viability. So if you're putting something in there, add it. You know, if you want to put in a full greenhouse, you better be able to justify why you did so.
And the next question is very similar. Beyond habitation, what other functionality will be required within the HAB, such as lab space, sample storage, et cetera?
Yeah, and again, that's up to you. There's the minimum requirements. If we have two competing concepts and they weigh the same and they cost the same, but one has twice the utilization as the other one, the one with twice the utilization will win.
Fair enough. What research will be conducted on the moon, and how should we prepare for that?
Well, so again, there's plenty of publicly available information about what we want to do on the moon. Go look it up, and you value what you think is best that works with your habitation concept.
All right, sounds good. Do the activities that the astronauts do during their stay need to be considered? Should experiments be designed for the astronauts to conduct on the lunar surface?
All right, so this answer is really, it's a two-part answer. Do the activities that the astronauts do during their stay need to be considered? Of course, you're accommodating the crew for 30 days or so. You have to know what they're going to do. They're going to go inside and do EVA, those basic minimal functions. But don't design experiments. You want to design a space for experiments to be done in and allocate power and data and stuff like that. But don't do specific experiments that are unique to your design. You want to pull those experiments from what you find available in the available research.
So I think you just addressed this, but what laboratories or designated spaces should the initial habitat have?
Same as the above. Yeah, same as the above.
All right, will we be responsible for the cost of the trip to the moon, or are we only concerned with the habitat's resources and equipment?
No, you have to cover the whole cost of getting to the moon. So that goes back into the CONOPS of launch, landing, and if you decide to offload it or not, how you would do that. So the end-to-end mission description of how it goes from Earth to the lunar surface and becomes operational, and the costs associated with doing that.
Okay. Question 13. Do we need to consider the initial launch from Earth in the concept of operations of the HAB, or can the CONOPS begin with the habitat element sitting in a lander on the moon?
So we just said all this, and then this is where I mentioned the three lander contractors. So we would like you to look towards what they're thinking about. Think about how one of those human landers, if it turned into a cargo lander, could land your particular habitat configuration. And you'll notice there's quite a range of capabilities that could be accommodated by those three contractors. One goes from very small, about 5 meters, and one is the SpaceX Starship, which is an entire lunar outpost all by itself. So be careful not just to pick the easiest, obvious answer, because a lot of other people might do that too. So think about being unique and innovative with any one of those three lander concepts.
Is there a volume restriction on the habitat?
As I just said, the various lander concepts have different things. There's a minimum, which is keeping the crew happy for 30 days. But there's technologies like inflatables or maybe a large shroud or something. So there's no minimum, but you want to stay in the mass constraints and the launch capability constraints.
And should we anticipate lunar dust being a potential habitat risk?
It was 50 years ago, so I imagine it still is.
All right. Will we be including the astronaut suits in our budgets?
No, think of that as provided by NASA.
And what are the power limitations for equipment and utilities?
Well, it's a function of your design. Of course, you have to bring your own power with you, so there won't be a grid to hook up to. So this needs to be self-sufficient from a power and energy storage perspective. So there's no limit on how much power you can generate if you have a fusion reactor, but you won't get any serious points if you say I'm putting a fusion reactor on it. So think solar.
Do we need to establish a comm link between the two astronauts, or is that provided?
Well, assume it's provided. Of course, you're going to have communications capable in your habitat so they can go to it, but you're not the relay for the two astronauts because they'll be on the moon long before the habitat gets there, just doing quick sorties. So that problem will be solved.
All right, question 19. Are food and water provided for, or will they need to be taken into consideration?
So they'll be delivered separately because, of course, every 30 days you run out of that. So you have to have a logistics system. But you want to figure out how a next set of logistics are brought into the habitat, or how nitrogen is pumped into it, or how oxygen is transferred. And then, of course, you want to consider how the waste is processed too, because you don't want to store crew after crew after crew rotation of waste in the habitat. So things go in, things come out. You have to figure out how to do that. And of course, food, you're going to prepare it and store it while it's in there. So you have to accommodate those things.
All right. So we received a lot of questions very similar to number 20. Does the 6,000 kilogram dry mass include all of the components of the mission, including consumables such as water, food, etc., for the initial 30-day mission? Or is that just the lunar habitat's weight?
So I'll tell you how NASA is planning on doing it right now. We're bringing down our initial logistics with us because it's more mass efficient to do it that way. That is not a requirement. If you want to use every bit of that 6,000 kilograms for your habitat without any logistics in there for the crew, then you can go ahead and say, all right, well, we're going to have a separate logistics flights, and as soon as the crew gets there, they have to put it in there. That's not an operational advantage, but it might be a mass advantage. So it does not include it. Doesn't have to, but it can.
Understood. Okay, same question, 6,000 kilogram dry mass. That's required to be transported to the moon via commercial transport in a single vehicle launch, or could it come in multiple launches?
Well, so here's, let me give a more operational context here. So prior to this habitat being delivered, we'll have crew on the moon, and they'll be living out of their ascent module. But we want to get to the point where we're sending 4 crew down, where 2 will go live in this habitat and 2 will go in a pressurized rover. So that habitat has to be ready for occupation as soon as the crew lands. So there's a 6,000 kilogram limit, and when the crew arrives, they have to go into it and start living in it. Now, it doesn't have to be finished at that point. They can outfit it or set some things up, but we can't have 5 little flights, or 6 flights that are in 1,000 kilograms each, and somehow they screw together and inflate. That's not what we're looking for. We're looking for a single monolithic piece of equipment that is landed that the crew can go live in as soon as they land.
All right, because water and oxygen are critical factors for the mission, would getting into the ice and using the electrolysis or other processes to get to the resources we need be a viable and good way to start?
So it's not a viable and good way to start, but it's a viable and good way to finish. And this habitat is more of the construction shack for the lunar outpost. So this comes before all that stuff is up and going. So the answer is outside the scope of this topic, but really what it means is that don't plan on that stuff being there and up and running to leverage it. You're going to have to bring your own logistics with, have it delivered or bring it with you.
Can we utilize the Nokia cell network on the moon if it's currently slated for 2028?
If that is your assumption, state it, and just make sure you have enough power and equipment allocated to interact with it, whatever it is. Maybe that's just a cell phone. I don't know. It's very minor compared to the mass of the rest of the system. Again, a lot of assumptions like communications you can state. Just make sure you have a good a technical solution that supports your assumption.
All right. Question 24 under theme 1. How many missions can we run for the purpose of assembling the HAB?
So I just answered this question. Again, one large monolithic chunk that's ready for the crew to get in. Again, if the crew wants to get in there and push a button and expand out something inflatable, that's great, so long as they can get in there after they land and start working on it.
Do we need to make a plan to land the habitat? And should we be concerned with plume impingement upon landing?
So ditto on land the and plume impingement's important. Again, the habitat will be on the lander, the plume impingement really is anything else going to plume on the HAB eventually, or is the HAB when it lands going to plume on something else? So it's a consideration, but for the most part, in this scenario, the habitat will be on the lander that's doing the pluming, and you just want to protect from that.
Can we design the habitat with a specific location in mind? For example, in a close proximity to a lava tube?
Absolutely. again, that this habitat will be a foundational element of the Artemis base camp, which is at the lunar South Pole. If there is a lava tube in a region that's close to where, within 5 degrees of the lunar South Pole, that's also close to areas with high concentrations of solar energy and maybe water deposits, that might be a good thing. If it's all by itself and it's beyond the capability of the human landing system to get there, or it's in the dark all the time, that might not be a good place to put it. So be careful with your assumptions, because this is a foundational element of a larger base camp. It is not just a one-off.
All right, question 27. Can we consider designing the habitat inside of a lava tube, which you just addressed?
You can, given all that other constraints.
All right, and are the 2 astronauts, will they be in charge of habitat assembly?
So again, it has to be livable once they land, but whatever they're assembling and outfitting and fixing at that time, yeah, because the other 2 astronauts are going to be driving around in a rover. So, as it says, it's up to you to figure out how that is. Again, they will not be assembling a big habitat. They'll just be outfitting and deploying things of the habitat that they're actually living in.
All right. And is habitat construction period included within the required 30 days? So if the habitat takes 3 days to build, should the team prepare for 30 or 33 days?
So as I said, this is a nuanced answer here, because if it takes them 3 days to finish deployment of the habitat as they're living in it, that's fine. If it takes them 10 days to finish deployment and outfitting of it as they're living in it, that's okay too. If it takes them 2 days before they can live in it, that's a problem. So again, think about ready to move in, but you have to hang the pictures and stock the kitchen.
All still within 30 days.
Yeah.
All right. Can we count on a crew of astronauts that would go and commence assembly themselves, or does it have to be rover operated? Just address.
Yeah, again, it's got to be raised up.
All right. Would the design of a habitat that would be developed using 3D printing and lunar dust fit into the parameters and restrictions of this theme, given that the design would be reusable along with a 3D printing machine?
So if you've got this scenario where a 3D printer goes down and has robots and scoops up dust and builds a habitat and outfits all this electronics and does all that stuff, and it's ready to go when the humans get into it, and all that stuff weighs less than 6 tons, more power to you.
And a follow-up question asked if using a third party specializing in 3D printing be allowed, which you also just addressed. So moving on to question 33. Do we need to employ a pre-existing communication solution or have the freedom to implement your own?
As I said, state your assumptions and back them up.
Are we assuming XEMU, which is the spacesuit, use on missions with this habitat?
We are, and I'll say that there are 2 versions of the XEMU that we're currently considering for use with the habitat. One is your basically typical spacesuit. The other is a suit port version of it, where you have a suit lock on a suit port on the back of it, where actually you snuggle up to an airlock, take the hatch off, and go inside without transferring any dust. You're free to use either version of that XEMU. You won't find as much information on the suit port version of that out there, but there is some out there in the community.
And is there a resource for temperature or radiation data within the polar region?
There's lots of them. Go Google it.
Fair enough. We're not giving away all the answers that are publicly available. All right. Are we basing the mission length on days on Earth or on the moon? Good question.
Well, okay, so Earth days. It's more tricky when you get to Mars, because a Mars day and a Moon day and an Earth day are sort of similar, but yeah, Moon day's a month, so no, Earth days.
And how much should we consider possible theoretical innovations that can be used in the mission compared to what currently exists?
So again, we're talking about the 2028 timeframe. That's in the engineering development cycle. That's pretty close in time. But there are capabilities that are evolving quickly on Earth, like automation and robotics and energy storage. And if you can make a reasonable estimate of where those technologies may be in 2028, if you could, assuming that you could start engineering into the system 4 or 5 years before that, state it. But you have a limited budget, and you have to have some things, as we said, that can be demonstrated to be mature to the proper TRL level in that time frame.
Can you be more specific on how reusable is defined in terms of this HAB?
Yeah, so basically reusable means that at the end of the 30-day mission, the crew goes home, they throw out their garbage, and then a year later, another crew comes down with some new logistics, and they get in there and they use the habitat again.
All right, perfect. Do you consider it important to ensure the emotional health of the individuals who carry out expeditions? And if so, what factor do you consider to be the greatest risk for emotional health?
So there's lots of research there out on that subject. Needless to say, people in extreme environments locked into a small space are stressed out. So it's very important to understand that. And that should factor into your habitat design, whether that be a window or smaller separable spaces where they get some privacy and talk to their family at home. Research it. There's a lot of good thought processes behind it.
Perfect. And I'm going to skip question 40 because we've addressed this several times. Moving on to question theme 2 questions, looking at the minimum Mars ascent vehicle now. And I did receive a few questions in the chat that were sent to me privately about the lunar HAB, and we will be addressing those at the end if we have time. Right now, we're going to go through all of the questions that were received in advance. So hang tight, we will get to you. First question under the minimum Mars ascent vehicle theme. What is the definition of low Mars orbit? Are there general recognized numbers for what constitutes as LMO? Can we assume similar altitudes as low Earth orbit? Or can we assume LMO is determined by an orbit that experiences none to minimal deceleration caused by Mars' atmosphere? Is there a particular range or altitude for LMO?
So again, we're looking for you guys for innovation and advice and ideas on what the right low Mars orbit is. As I said here, it's, you don't want to go so low that you're picking up drag and dust. You want but going low means that makes that Mars ascent vehicle as small as possible. Also, what's interesting about lower Mars orbits, and I'll say lower instead of low because we're talking about a class of lower Mars orbits that you choose, is that your time for repeat to ascend to that is a lot faster than higher orbits. If you go to a 5-Sol Mars orbit, that's like 5 days until it comes around again. So your MAV has to be designed to accommodate a crew for longer durations. A low Mars orbit takes less propellant. It has smaller crew accommodations because you don't have to keep them happy. You might not even need a bathroom for a MAV that goes to low Mars orbit. So that's what we're getting at. How low can you go? And again, document and justify and do the orbital trajectory analysis so you know your rendezvous periods and things like that. So that's the same for 2.2.
So apply the same concepts as limbo. How low can you go?
Exactly, without failing.
All right, and then we received a bunch of other very, very similar questions about the orbit relative to Mars surface, and you just addressed them all. So we're going to skip over the next couple ones. Go ahead and go to the next slide, Jen. Do we have the authority to decide where the launch site is on Mars, or are we going to be given a specified landing or launching site?
So yes, if you want to assume that you're going equatorial because that makes things easier for you, then go right ahead. However, if someone can design a MAV in a rendezvous architecture that works well at higher inclinations where there's ice deposits below the surface, we'll look upon that more favorably. So there's ease of implementation and there's mission capture. That's a trade that you guys have to make.
All right, skipping over question 7, it's been addressed. And question 8 has been addressed as well. Let's continue on to the next slide. Is the orbiting vehicle the transport vehicle back to Earth?
So again, we're sort of leaving this open. You can state, what you think your ConOps are going to be, but we're not expecting you to size, design, if there is a transfer vehicle or the main vehicle. NASA itself is doing internal trades about how low do we want to go to pick up the crew, and a taxi or intermediate vehicle is certainly in the trade space. State your assumptions for your whole integrated architecture, but you're not costing that, you're not designing it. So if the thing is, though, if you pick a low Mars orbit that has a decent drag on it, and you're planning on either a Mars transport or a intermediate vehicle to get there, staking that the vehicle there for longer times prior to the Mars ascent vehicle may introduce a risk. So you need to take the comments into consideration from the math perspective, but if you want to assume a transfer vehicle, that's fine. And of course, that's the easiest thing from the math perspective to do. Of course, that puts an extra burden on the rest of the transportation system.
All right, skipping over question 10 and moving on to 11. For the rendezvous with the Earth Return Vehicle, or ERV, is it in a predetermined orbit with a set inclination, or can we set the ERV inclination ourselves to limit propulsion needed for costly orbit changes? Can we assume that the ERV is at the same inclination as the orbit that we eventually reach?
So you can assume that after, and this goes back to the inclination perspective, if you want to state in your assumptions that you're going to require the ERV to rendezvous with your MAV or your taxi in a different inclination, state that. Just make sure you state it, and we know that you understand that will put in additional propulsion capabilities on the ERV, but that's okay.
Okay. Question 12. What vehicle will the MAV rendezvous to deliver the crew members? And what are the rendezvous requirements for the in-space transportation? Do we need to create a docking system for the MAV? And if so, should we use the standard international docking system?
So in NASA's current plans, yes, we're doing a pressurized transfer from the MAV to the transfer vehicle. That will be through our version of the International Docking System standard, which is called the NASA Docking System. But there are other ways of doing this. If you want to be truly minimal, you might want to do EVA, because I don't want to take the cost of that NASA docking system up with me on both vehicles, because now I don't need it on the other. Well, I still need it on the other vehicle. But it's cost versus risk. So you have to make those trades. If you want to do away with a pressurized docking and go EVA between vehicles, not only have to understand the risk associated with that in the MAV operations, but you also have to convey to us the additional risk and design requirements implemented upon the rendezvous vehicle. So, for example, if I have to have an airlock on my rendezvous vehicle, that's adding more mass and weight to it, which will probably swamp any savings you would get by not having an NBS on the MAV itself. So be aware of those trades and balances from your system to others and identify them. You can certainly choose to not use a pressurized docking system, but you need to identify the cons associated with that decision and the pros.
All right. Question 13. Is it a 5,000 kilogram dry mass and 20,000 kilogram wet mass? Or if we decide to use the 5,000 kilogram dry mass constraint, can the total fueled weight be more than the 20,000 kilograms?
All right, so to simplify things, we have said that the EDL capability will be able to deliver to the surface of Mars 20,000 kilograms, whatever that may be. So you get 20,000 kilograms to the surface of Mars. We're also telling you that the dry mass of the vehicle and everything can't be any more than 5,000 kilograms, because it'll start to blow up after that, and it keeps everything leveled. So it drives you towards that. So that 5,000 kilograms has to contain the crew, the air they breathe, the water they drink, the samples, everything. It's all that stuff. So basically, from your perspective, you are lifting your MAV with all the stuff in it will weigh no more than 5,000 kilograms. If you can go less than that and demonstrate it, wonderful.
Okay, and you just addressed question number 14 as well. And 15, I'm pretty close, but just to clarify, does the dry mass requirement only include the structure of the ascent vehicle? And does the wet mass requirement only include the ascent vehicle structure and fuel? Are the masses of scientific payload, crew, provisions, etc. included?
Yeah, all that stuff is up to the 5,000 kilogram dry mass. So it's all included in there. That's just to help normalize things.
All right, 16 is the same. 17 has been answered. 18 has been answered. Let's move on to question 19. A little bit of extra clarification here on 19. Are these mass requirements for launch from Earth, Mars, or both? For example, if the propellant is Mars derived, is there still a 20,000 kilogram wet mass limit?
Yes, again, that is what can be delivered to the surface. So you get 20,000 kilograms per lander to deal with, whatever you want to be down there in order to enable your mission and your math. So, but a one lander solution that uses ISRU, if that's even feasible, would be looked upon more favorably than a three lander solution where I land 60,000 kilograms of stuff and I just transfer propellant and get the nav back up there. We're looking for the smallest nav, not possible, that's reasonable. And we're just saying that there's a payload system that is capable of delivering 20,000 kilograms wet to the surface. So in a perfect world, if you could design a MAV that was fully fueled with 20 tons that could get up to some low Mars altitude, you would meet the requirements. It would be dropped in one piece, no refueling, no ICU needed. It would just go, it would just be there ready to go when the crew went back up. So that's sort of how we captured it that way.
All right, question 20. Can we use other external structures, such as a launch pad, in addition to the ascent vehicle for its launch? Are there mass limits for these structures?
So much like in the earlier lunar campaigns, this is early. This is not late. So there is no infrastructure. There's no buildup of anything there. So it's launching by itself.
Okay. Pat, there was just one quick follow-up question on question number 19. Is the ISRU material included in this mass budget? It's a little unclear.
So not local material, but the material required for your power and your processing, your liquefaction and your storage. Yeah, that all comes out of that 20,000 kilogram wedge.
All right. Question number 21. Is the orbiting vehicle manned?
Again, the answer is possibly. If it's a taxi, probably not. If it's the Earth return vehicle, yeah, there'll be a couple of crew up there. Explain what your CONOPS mean and why you think it should be manned. Again, you're not designing that vehicle, but if part of your CONOPS with the MAV require people to be there, you need to justify and explain it.
All right, we're going to skip 22. That's been answered. Let's go to 23. What communication hardware is on the orbiter, such as radio and antenna specs?
Yeah, and again, just describe what you need. State your assumptions.
What are the current technologies for oxygen generation on the ISS?
Look it up.
Does the yearly budget include other diagnostic expenses and building a fuel factory on Mars or explicitly on the MAV design?
So if your MAV depends on ISRU fuel propellant production on the surface of Mars, that is coming out of your landed allocation and it is coming out of your budget, so you have to cover it.
All right.
So again, to be more clear here, we're looking for the least expensive, viable near-term approach of getting people back off of Mars. This is not for the long-term horizon thing where Elon has built his city and we have all this stuff going on. This is the initial first touch on the moon, on Mars. So everything to get you back comes out of your budget, except for the in-space transfer stuff.
Great point to keep in the back of your mind through the entire design. All right. Question 26. Is there an available NASA engine development roadmap or engine reference manual that you can recommend?
No, we can't because, we're talking about something that's, 15 years off here. There could be all new classes of engines there. Just any engine that you come up with either has to be, consistent with historical norms, perhaps slight improvements, or relatable to something that's being proposed in the near term. And of course, it depends what your propellant choices are too. So it's up to you.
Okay, the next question is about astronauts and spacesuits. Is there a specific average astronaut model in terms of size, mass, and a combination that we should assume? Also, what type of astronaut spacesuit can we assume? Or are we designing and choosing one as part of the proposed effort?
So again, there are guidelines for NASA's on astronauts and stuff. Personally, I always push back on them because they want to design NASA vehicles for a wide spectrum of potential crew, ranging from very large males to very small females. My preference would always be for 2 small females because they take up less space, they weigh less, and they consume less. That's my personal bias. So I did say here, if you want to push back, if you can demonstrate a savings in your MAV by going with a different size crew member as a standard. Remember, we're only talking about 2 people out of like 10 billion at this time. I'm okay with that, but you got to justify it, and you got to identify that it does not meet the NASA proprietary requirements of sending football players to Mars.
Question 28. Do we need to consider redundancy for E-Class?
Certainly should.
And 29, can you confirm that we do not need to consider EDL? For example, we only need to consider the ascent portion.
That is true. Now, one of the things that I'm not sure that we did say, we said 20 tons to the surface, but we're talking with like an 8.4 meter diameter shroud. So you shouldn't assume that your MAV is going to be 10 meters wide or 50 meters wide or something like that. Chris, I don't remember if we put that in there, but we do want to constrain them to the current SLS/SpaceX size shroud.
Which was 8.4 meters?
I think that's correct.
Question 30. If we choose to do ISRU, do we simply need to specify the method of capture and production and estimated costs for sending the IRU systems, or will additional details be required?
So long as you estimate the volume, the mass, the power consumption, and the cost, and whether it could be viable in that time frame or not, you can choose to do ISRU. But again, it's not free in any means. It costs you no matter what you do. It's like that commercial. You can pay me now or pay me later.
Okay. Question 31. For fuel production, if we do go the ISRU route, does the mass of the refinery system impact the overall dry mass requirements, or do we simply need to pay for launching the refinery out of the annual budget?
Okay, that's the same thing. It's coming out of all your budgets, mass, volume, and cost.
Perfect. What are the core requirements for the structural system? Does it only need to transport 2 humans to the mothership, or are there any other cargo requirements?
So certainly the 2 crew members, but of course we're going to Mars to do science and look for signs of life. We'll probably bring back things like ice cores. So again, the minimum requirement is 2 crew coming back, and they planted their flag and gotten some good pictures. But that would certainly be a waste of resources if we could bring back a couple 100 kilograms of great samples. So we'll leave that up to you as to what the value proposition of your MAV is.
All right. Will we be transferring anything besides the 2 astronauts to the orbiting vehicle?
So as mentioned in the last one, it's got to be more than a 2 crew. There'll be samples and mementos. So if you can, we'll go back and, say we'll say it's a requirement. Okay, 100 kilograms of stuff that you'll bring up from the Mars surface, and you'll transfer to the awaiting transfer vehicle. So 32 should be, the answer is up to 100 kilograms.
Perfect. Question 34. For health and safety considerations, is there any scoring associated with flexibility of getting an injured crew member back to the return vessel?
We always score innovation and good design. And again, all things being equal, Design A knows how to get the injured crew member in, and Design B didn't even think about it, Design A will win.
Good answer. All right, I'm not going to read the entire question of 35, but it's basically, it was multiple questions asking about the starting and ending point for the mission timelines. Where does our role start and end? And what are we responsible for?
So again, it goes back to there is a EDL capability capable of dropping 20 tons to the surface of Mars. You are required to give us your design and mass and cost for every system required to bring the crew back up from the surface to an awaiting transfer vehicle. If that takes you 2 20-ton landers worth of stuff to accommodate, you have to cover all that. If it takes you 1, you have to accommodate. If it only takes you 15 tons out of 20 tons, then that's what you report on. So every piece of infrastructure required in the critical loop to get the crew back up to orbit from Mars, you have to cover, cost, identify, design.
Perfect.
None of the in-space systems is on the table for you guys.
Okay. And I think we have addressed 36. Is the transit vehicle that takes the astronauts from LMO to their in-space transportation a separate vehicle from the ascent vehicle? And is this something we'll design?
As I said before, just design the nav, but it state your assumed architecture that the nav has to work with and any risk associated with that particular architecture from the nav perspective.
Is there a specific rubric for the Mars ascent vehicle theme in addition to the general final scoring matrix? And is the goal of the competition to make the lightest vehicle possible? Are extra points awarded for a lighter vehicle?
So certainly no extra points for a lighter vehicle. Again, as I said before, it's a combination of innovation, mission capture, functionality. That's what's going to win it. And the folks who think about all aspects of it instead of honing down on a particular item or subsystem come out much more favorably because they thought about the thing and the total mission concept. So innovation and safety and mission reliability and cost, they probably will outweigh the lightest.
And I think I'm going to add on to your answer, Pat, that we don't have individual scoring matrix for each of the different themes or matrices for each of the themes, but we do have a separate scoring matrix for the proposal that's different from the final scoring matrix. So please do look at the deliverables and specifically look through the proposal section, and you'll see the evaluation criteria for the proposal listed there. So make sure that everyone takes that into account as well. Question 38. Are we planning for one mission, or are we making our design for several missions? Would multiple launches be from the same site on Mars? Can the MAV be reusable? Are extra points awarded for reusability and lifetime?
So there's no extra points for reusability and lifetime. Again, I've said this is the first boots on Mars type approach. But if you can put those features in there at a reasonable trade for cost and risk performance, it becomes innovation. And we score innovation, we favor innovation in this competition. So no extra points, but you might receive a more favorable rating.
Fair enough. Do we need to provide long-term life support in the MAV, or will it be provided by the in-orbit space transportation vehicle?
So if your MAV mission lasts any more than 5 days, you probably don't need to think about long-term life support. They're not living in the MAV on the surface of Mars. It's just during the transit phase. They hop in and go.
Okay. Is the $2 billion yearly budget for the MAV concept or the interfaces supporting it and the launch to the Martian surface? For example, if Mars-derived propellant is used, would the cost of fuel production be a consideration?
So, yeah, this is sort of hairy and stuff like that. I mean, we talk about dropping things to the surface. So we're asking you to cost everything that is dropped to the surface, not the EDL, not the launch of that stuff, but all that particular hardware. So not the delivery, it's not the launch, but it's the actual hardware that ends up on the surface to enable your math. That's what the $2 billion years is for.
What does it mean by annual budget of 2 million? Can we spend more than 2 billion in one year and deduct that from the following years?
We would love that to be the case within the government, but it doesn't work that way. We have to take a typical program lifestyle has these peaks and valleys, and they give us money on a flat basis for the most part. So we have to work with that. So you guys have to work with that because that's part about learning how the system works. So no, you can't borrow and credit money from one year and put it in another one. If you don't have enough money, you have to slow down, and then you catch up when you do have more money.
Okay. Question 42. Do we need to calculate into the budget not only the materials used, but how we're procuring them?
So procurement mechanisms make a big difference. If you notice in our current lunar program, NASA has decided to go with competitive commercial contracts for lunar surface access, as opposed to a traditional, cost plus fee model that we do within NASA. So the mechanisms make a difference in the cost. State your assumptions in your proposals and line your cost up with it. And, if you want to say we're going to save 20% by going commercial, if you can find some history that justifies that, then do so.
Okay, and we're going to have to pick up the pace if we want to get through these questions, so starting to read a little faster. How long would the MAV be expected to stay in the orbit around Mars?
That all depends on your strategy, what orbit you're going to, and how many missed opportunities you want to have.
And the same answer applies to question 44 about the length the MAV is expected to stay on the surface. So moving to 45, how long will the mission profile require the astronauts to be on the surface of Mars?
30 days.
Question 46, what ground systems can be assumed to exist on Mars?
Whatever you cost to be there as part of the MAV. We talked about this too. If it's not assumed to be there, you're paying for it. So it's part of your MAV system if it's needed to get the MAV back up into space.
And will the MAV be landing on the surface with astronauts aboard?
Nope, not in this architecture.
Will the MAV be required to make multiple trips between the surface and orbit?
No, it will not.
Can it be assumed that some astronauts will stay in LMO for command?
That would be a good assumption.
Will the MAV be expected to dock with the Earth-Mars transfer craft in LMO or some immediate vehicle?
As we said, that's up to you and how you want to do it.
How should we quantify the timeline of different engineering processes of our design and construction processes?
So again, that's up to you. That's part of what we're rating you on.
Is disposable multi-staging allowed? Do we have to return with the same structure that leaves the spaceship?
So certainly staging's allowed. 1 or 2 stages is they're all good. Depending on how small you make your MAV, it may be advantageous. It may not be. And no, once you're done with the mission, you're done.
Question 53, what level of detail are teams expected to go into regarding the pre-competition deliverable parts of the mission? For the MAV, this would be the phase prior to the ascent vehicle departing Mars.
Yes, yes. Certainly everything leading up to the departure and the mission where to go in it, you need to document with respect, especially you're taking into account things like ISRU, where that's part of your critical function. So again, you must demonstrate this understanding of the realistic trade space for all this stuff, and then tell us why you made decisions and design choices.
How much weight is necessary to transport as cargo outside of the astronauts?
All right, so we said everything, it doesn't add up to more than 5,000 kilograms. And in that is included all your cargo, including a 100-kilogram sample.
If we had another payload, would we have to pressurize it in some way?
Depends on what it is.
What exactly do we have to worry about during the mission? Are we to also worry about going from the habitat to the MAV, just the MAV, or from the MAV to the other space station?
You're just climbing up the ladder or going through a tunnel or however you're going to get into the MAV from the surface and then getting from the MAV to your transfer vehicle. That's your mission.
How long do we anticipate the time in orbit for the astronauts to stay in orbit?
It could be as low as 50 days.
Can we assume that the spacecraft picking up the astronauts has an airlock on it? And do we consider docking and how it integrates with the systems in the other spacecraft that pick up the astronauts?
Absolutely.
Yes and yes. If we're using existing Mars resources for our fuel, are we responsible for explaining the process of gathering and processing those resources?
Explaining, paying, developing, and landing, yes.
Is our payload only going to include the 2 crew members, or will we have to account for additional payload?
They're in that 5,000 kilogram maximum.
Can we assume crew members will have access to breathable air via their spacesuits, or should we design the dedicated system to provide cabin with breathable air?
That's a function of how long you have the crew in there, how many contingencies you want to cover, and your transfer methods.
Should or how should future technologies be implemented into concepts? How accurate must system readiness timelines and technology portfolios be?
So again, we don't want people assuming warp drive and transporters. So you got to demonstrate how the technology is matured to operational status prior to your mission date, and how you pay for it.
And how detailed do judges want teams to go into in terms of engineering analysis and component considerations?
Well, as I mentioned before, there's some teams who go into an extreme amount of detail over something that's state of the art, just to demonstrate they have the capability to do analysis. We don't need to see that. We want to see analysis and simulation applied to areas where you're making trades and you have tough decisions.
Perfect. So you don't need to see every nut and bolt and the list of their size, location, and number and all that, but an overview and visual of how it's used.
No one should be showing us a structural analysis of deflections of a bolt.
Perfect. All right. I think, Pat, you get to take a break on your voice as we turn the microphone over to Dr. Jones to answer the questions for Theme 3, the Venus Flyby Mission. Chris, your first question under the Venus Flyby Mission theme. Are there any constraints that would prevent us from bringing animals, in particular rodents, on board as a part of the science payload?
No, just need to account for those in your system design.
And can we build an orbiter and launch separately, or bring an orbiter as part of the payload?
So the orbiter could be part of the payloads you're delivering during the flyby, but you do need to account for how you're transporting that and deploying it as part of your mission design.
Is our budget specifically for the designs, or does it include operational cost?
It does include the operational costs.
Are there any I think this is the same one. Let's see, question 5, we'll skip to 5. Would it be beneficial to design a mission that's reusable? For instance, a potential future use could be used for a secondary long duration mission, or as another space station orbiting Earth after the Venus flyby.
So similar to for some of the other questions, if we could get reusability, that's great, but you would need to make sure to impact or account for the impacts of having that reusability, and remember to make sure to achieve the basic mission we're asking for, and don't sacrifice that for the expense of making it reusable.
Okay, question number 6. What are the main concerns or technologies that NASA wants to have tested in regard to future Mars missions? Such technology concerns include waste management, sustainable food solutions, etc.
So this Venus mission is going to be a stepping stone to a Mars mission, and it's the first time to really send humans on a long duration trip away from the immediate vicinity of the Earth and the Moon. So there's a lot of capabilities that are going to have to be sustained for more than a year without the ability to resupply or repair from Earth. So use that fact that that's the nature of the mission and what we're testing here to guide you in selecting the areas you want to address.
Okay, next question. And actually that is it for the Venus theme. So that was a quick theme to get through. Moving on to theme 4, which is the human mission to Ceres. The first question under that theme: are we allowed to assume analogs of current or near future space elements, such as ISS, Lunar Gateway, etc.? Are we allowed to assume they will exist during our mission timeframe, as neither are currently funded for operations between 2035 and 2050?
So yes, within reason, you can assume that there will be some analogs. There will very likely be some crude human presence in space near the Earth during the timeline of the Ceres mission. But don't then assume that, for example, such a thing would then also be usable as the habitat for your Ceres mission, and thus you don't have to pay for that.
All right. Next question, number 2. Is the 5-year total mission limit in reference to crewed operations? Would a preceding uncrewed split sprint be acceptable, or is the 5-year limit defining first launch to system end of life?
So the 5-year duration here is for the crewed mission. If you're pre-deploying other systems beforehand, you can account for that outside of the 5 years.
Moving on to question 3. What qualifies as a landing on the Ceres surface, EVA or no EVA?
So an EVA is likely going to be needed, since we often think of a crewed landing as having an astronaut's boots on the surface, and specifically with an astronaut in those boots.
Okay, we'll skip over question 4 because it was already answered. Can we assume NASA's radiation and bioastronautic standards are applicable?
Absolutely.
And what are the requirements or assumptions for the astronaut crew selection?
So I would say start from what NASA currently uses, but it may be worth considering if there's significant changes similar to the answer Pat gave for the Mars MAV mission there, if you were to constrain the requirements and how that might impact your system.
Okay, question 7. Do we need to propose a specific location on Ceres for the mission?
Not unless it significantly impacts your concept of operations.
Is there a max limit on delta V's or available rocket technology?
So you do have to consider what could credibly be developed and implemented by the mission timelines at the current levels of technology investment by NASA. So yes, we're pushing for advanced propulsion. Yes, there's going to almost certainly be better capabilities in the 30s and the 40s than we have today. But at the same time, don't expect suddenly to have, warp drive or something else super exotic.
How much thought should be given to landers and other materials from the mission being left on the surface?
If any of the systems are going to continue performing some function after the mission, we do want to know about that.
Question 10. How much of the mission infrastructure can be supported by commercial partners?
So they can definitely contribute, and I expect we would want to leverage whatever commercial services might exist then.
And you don't.
We're getting a little bit of feedback. If somebody has their mic turned on, maybe take a peek and see if your mic is on or off. If you could mute that for us, thanks.
So yes, we could definitely have contributions from commercial partners, but keep in mind they're probably not going to be paying for a mission to Ceres out of the kindness of their hearts and their own budget, and so they're expecting to be paid out of the budget we give in the mission.
Can we send preliminary infrastructure payloads ahead of the crewed mission?
Yes, you can.
Question 12. What specifically does the proposed budget need to include? What fidelity does the budget proposal need to have?
Okay, so there's not one specific level we're looking for here. You should provide enough detail that the judges can assess if your plan is credible. So just telling us, the final cost is going to fit within the budget cap and we're good, that's not enough. But we're also not expecting to flip through multiple pages of very detailed budget breakdown over the years. Consider, for example, how you might make the case to a student or a professor who's unfamiliar with the theme that you have made a reasonable budget. And if you think about it in those terms, that will probably help guide you in making a similar case to the judges.
Should our budget include time and resources prior to 2035, or are we to assume that we have zero budget before that time?
So there won't be any budget for the Ceres mission before 2035, but there may be some systems or capabilities that are developed that you might leverage that have been developed before then. So look at some of the things NASA currently has in its future plans, and you could assume that those would then be available to leverage for the Ceres mission.
Okay, question 14. In light of missions that would most likely need to happen before Ceres, do we need to consider all aspects of needed technologies in our R&D budget, or can we assume certain technologies will be ready and available? If you just
Same answer as you gave for the previous one.
Is there a list of potential missions that may come before this mission that we should consider?
So NASA has put out some thoughts about the plans for the Artemis set of missions and future missions to Mars, and both of those would be intended to take place before Ceres, so take a look at those.
Is there an available data set or plot of time and space versus health risks for astronauts? And what are the current guidelines on these risks?
So there are papers that go out there and that discuss that. We've actually just added one to the recommended reading here that talks about the impact of a mission to Mars, and you could use that as a starting point to think about how health risks vary as a function of time for the Ceres mission.
Okay. Question 16. Oh, no, we just addressed that one. I'm looking at other questions that are coming through on my chat. I apologize. Question 17. On the web page, which the RASCAL theme web page, the bottom of the theme 4 description includes a blurb about YSS. Was this paragraph meant for theme 5, or is theme 4 intended to conclude its mission at the ISS as a requirement?
So yeah, that was just a typo on the website. The ISS doesn't need to be a part of theme 4, and we've updated the description of the themes.
And that was my fault, so I apologize for that, everybody. It has been removed from that section. With NASA's current plan of sending a deep space transport to Mars after the Artemis missions, could we assume that our mission can use technologies from such DST, or deep space transport?
You can definitely consider that.
Could we assume that there will be an orbiting platform in cislunar space or in Mars orbit that can be used to build, resupply, refuel, and be used to maintain the transport or habitat for the Ceres mission?
So if you want to assume the existence of that system, you do need to justify why you think it's reasonable that it's going to exist. Maybe it's an extension of NASA's current plans for the Gateway, and that's something you can point to, as opposed to, for example, it may be harder to say, just assume into existence a futuristic space dock that assembles everything for you very easily. So you can make assumptions, but be sure to justify why you think they're reasonable.
Can we assume that a first shakedown DST cruise to some planetary orbit, such as Mars, has already been completed?
So yes, if you're, for example, planning to use the same deep space transport as is being used for the Mars mission, you can assume that it has been done that, but do then justify your assumption of why you think the system you're thinking of is one that would be used for Mars as well.
Okay, question 21. Is there a maximum allowable surface stay duration?
No, so you just need to keep in mind that the entire crewed round trip, leaving Earth to going to Ceres and returning, all needs to fit within 5 years, and that plus the orbital mechanics will dictate how long you can stay at Ceres.
So just to be clear, does the maximum 5-year mission duration include only the time that the astronauts can be in space, or the time from launch, all of the elements to the return to Earth?
So the 5-year mission duration is the time for the crew to be in space. So if you're launching elements years in advance of the crew departure, you do need to address how those systems are going to be kept dormant in space, but the 5-year cap is just from when the crew leaves Earth to when they return to Earth.
All right. 23. Does the $3 billion annual budget have to include the cost of manufacturing, assembling, testing, launch, operations, and maintenance of the DST and CCL?
Yes, it should include all the costs for the systems you need to do the Ceres mission.
Can we assume that there will be a functioning lunar base available by the time our mission to Ceres takes place?
So similar to what I said a few questions ago, you need to justify your assumptions about what you think might exist given NASA's current plans and reasonable extrapolations about how far we're able to get from those current plans by the time you're doing the Ceres mission.
Question 25. Due to the long duration nature of this mission, should we consider artificial gravity?
So you should definitely consider the impact of microgravity on the crew because they're going to be spending years exposed to it and how you would mitigate it. If you choose to go with an artificial gravity design, then make sure to address how that impacts other aspects of your design like propulsion.
Are you more interested in overall mission design rather than a detailed design of the spacecrafts?
So both of these are important, but if the overall mission design is not credible, for example, it's assuming an unrealistically advanced propulsion system, then it doesn't matter how well, for example, the interior layout of the habitat is designed. So make sure that your overall design is credible before potentially putting too much effort into the details of the vehicle.
Okay. Can we assume that key technologies for the exploration of Ceres can be tested on the lunar surface or in cislunar space?
Yes, though explain your assumptions about those technologies and what you think is necessary for them being tested, either on the lunar surface or in cislunar space.
Can we assume that there would be a precursor robotic mission to Ceres? If so, would the cost of such a mission be included in our budget?
So if the mission is solely to provide reconnaissance of Ceres, you don't need to account for that in the budget, but you should explain what this mission is. That might very well come out of a different slice of NASA's budget. But if you're talking about a mission that would be used to pre-deploy some of the systems you would use in space or on Ceres, then yes, that does need to go into your budget.
The requirement says that the mission has an annual budget of $3 billion per year beginning in 2035. Does this mean that the development of the mission can only start in that year, or can it start a couple of years before?
So you have to start the development of the systems for the Ceres mission in 2035. Now, if you're leveraging technologies or even systems that you can reasonably justify came from another mission, something from Artemis, something from a mission to Mars, you can assume that those have been matured prior to 2035.
Can nuclear thermal propulsion be considered as the primary method of propulsion for the deep space transport, even if it's a crewed mission?
Yep. Although do make sure to account for the design requirements that come from using nuclear propulsion on a crewed vehicle, for example, shielding the crew from radiation.
Why is ammonia on Ceres indicative of coming from the outer solar system?
Not really relevant to this, other than if you want to talk about that as a scientific exploration as part of the mission.
What in-flight mental health maintenance tool does NASA anticipate having available during a manned mission to Ceres?
I don't think there's anything specific. Certainly you can research what's been proposed for other missions or define what you think that needs to be able to do to support a crewed mission.
At what locations may the crew start or end the mission? Can the mission start or end with the crew at any non-Earth locations?
So the mission itself might start from somewhere besides Earth, but you need to account for how the crew gets all the way from Earth to Ceres and back. So for example, if the crew is going to wait at Gateway for an optimal time to depart, that is part of your 5-year clock.
All right. I think this is our final question under the Ceres theme. A preference was stated in the theme descriptions for concepts that can demonstrate ways to use less than the maximum annual budget. Is there any preference for concepts that can have a Ceres landing date before 2049?
Absolutely. If you can do it before 2049, that would be great, but do make sure that it's a credible case for being able to pull that off.
Okay, as we move to the next slide, this begins the questions we received for theme 5, the distributed lunar sample aggregation, analysis, and return to ISS theme. So Pat or Chris, which one of you would like to tackle these questions?
I'll do it, and Chris can correct me.
All right, go for it, Pat.
All right, first question in theme 5. Do we need to consider the Earth to Moon trip in our architecture design?
Certainly do, because if you just magically assume it magically appears on the moon to return samples, that's only half the cost of the mission. So yes.
And how detailed does the structural design of the lander and sampler need to be?
As we said before, it's deep enough to know that it's credible where it matters.
Will there be specified lunar sample collection locations we should focus on?
No, you want to find the best ones, but certainly include the South Pole of the moon.
Question number 4. How many locations or how much area should the device cover? Is there a limit to the number of locations or minimum distance between them?
So it's not a quick answer. In the context of using this device, we have a lunar exploration program with both robotics and humans. There will be a base at the South Pole where we'll gather samples and return them there and return them from the sample place. But this system could also be used for remote locations that are not at the outpost, maybe delivered via Eclipse lander or something like that. So as it says, use the lunar research goals, but think in the context of we have outpost locations where you can aggregate samples, and then you have other places on the moon where you could get them for direct. So that's part of your mission design and your mission capture.
For sample collection, is there a desired amount or number of samples that you're looking for?
Again, we're looking for your strategy.
And what is the expected duration of the mission?
Well, we'll return the samples by ISS, and again, we give them the goal of 2028, because maybe ISS won't be there in 2030. There are a lot of, why are we going to ISS here? Here's the problem. On the human systems that we have, we can only bring back 100 kilograms at a time in Orion. We're going to plan on getting a lot more samples from there and eventually back from Mars. We might take samples back to the Gateway. So if we had some methodology getting samples from the moon or from the Gateway to low Earth orbit where we have systems that can bring back tons of cargo, we'll be able to get more samples back. So that's the context for what this is in. That should head off about 6 questions.
All right. Question 7. Evaluation mentions that all RASCAL teams should support crewed and robotic exploration of the solar system. Does this mean that the mission is required to be both crewed and robotic?
No, it does not.
Can we perform experiments on Earth? Or experimentation?
Well, again, this goes back to we're focusing on ISS delivery. We don't want this stuff delivered directly to Earth. Been there, done that. We want it going to ISS.
What are the expected percentages of experimentation performed in situ on the ISS and on Earth?
Again, we're not looking for what you do with the samples when you take it to ISS. We're looking for gathering the samples on the lunar surface, whether robotically or fed by humans, and then bringing those to ISS. It doesn't matter what they do with it once they get there.
Are we required to conduct experiments on ISS?
No.
Does every hardware component of the architecture need to be an original design? Can pre-existing hardware like communication satellites from non-Artemis missions be used?
Absolutely.
Question 12. With our budget of $1 billion per year for 6 years, is this 6 years of development and testing and then we complete the mission after 2028? Or does our mission have to be developed, tested, built, and completed within the 6-year window?
It's the whole race. Everything's done within 6 years.
Is the specified budget of $1 billion per year include mission operation costs?
Yes, it does.
Is the goal to minimize costs or maximize gains given the $1 billion per year budget?
Well, you always want to maximize gains, but you have to fix within the cost box. There's other aspects of that too. That if you were to say in part of your analysis, but the second and third and fourth missions would only cost that, we'd be interested in seeing that. But your target is 6 years, $1 billion a year, so you can get it to work for one mission.
Perfect. How long can you cryogenically store liquid hydrogen before losing 10% of your total fuel mass? Is there anything in the works to significantly increase this time?
Yes, there's things in the works, but you have to research that.
Is there a database of commonly used materials by NASA?
Look it up.
And I'm going to add on to that one, Pat. We just recently had a call with the MAPTIS folks who have that database at NASA, and they have created a system for our RASCAL teams to be able to request specific access to that system. So we will be posting that on the resources page as well, and how to go ahead and request access to that system that NASA has.
Okay.
All right. Question 17. What is the best way to research potential landing sites? Highest definition images of the lunar surface?
So again, some of those resources that Stacey just mentioned, get hooked into them and start looking.
We noticed many NASA instruments have general information about them, but no spec sheets for things such as power and data consumption. Is there a common place for instrumentation spec sheets?
I wish there were, but there's not. We have to hunt just like you guys do. So a lot of time that's where you get a good connection with industry. You can find the company or the university that made it and talk to them and just state your source.
All right. Next question. Oh, and it looks like those are all the questions that we had received in advance. So we are getting ready to shut down this webinar here in just about 1 minute. So I'm going to ask if you have any questions, we'll leave the webinar up for just a few moments so that you can write down your question in the chat. I do have a couple that I've already been compiling, but if you have new questions, please feel free to add them to the chat. We will address them in writing on the FAQs when this is posted. And if you have any additional questions after this Q&A, please email us at rascal@nianet.org. And again, we'll respond to you and post them on the FAQs as well. So if you could move to the next slide, Jen, really quickly. Just a couple of things to make sure that everybody is aware of. The deadline to submit your proposals and videos is March 4th. 11:59 p.m., 1 minute before midnight. The form will close at midnight and we will not be accepting late submissions. So please make sure you get those in on time. You go to the form ahead of time and make sure you know what it's asking you for, so that you can be prepared to get that in on time. We'll let everyone know by March 29th if they've been selected as a finalist and provide some feedback to your teams as well on your proposal. And then we'll be looking forward to having your final designs presented to us at the RASCAL Forum, June 14th through the 17th, hopefully in person in Cocoa Beach, Florida. So I wanted to just thank Pat and Chris for their time. They are very busy individuals and spent the better part of the past 2 days responding to all these questions and looking some things up that needed to be looked up. And so we appreciate your time very much, gentlemen. Thank you for all of the wonderful questions that you all submitted to us from the teams. And best of luck to each of you all.